Good morning to everyone. This is a combinational circuits. A combinational circuit are the circuits in which the output at any time depends upon the combination of the input signals. That is the multiplexer, demultiplexer, encoders and decoders are the combinational circuits. So here we are going to see about the multiplexers. That is, the term multiplex means a many input into one. This multiplexing is a process of transmitting a large number of information over a single line. A digital multiplexer is a combinational circuit that selects one digital information from several sources and transmits the selected information on a single output line. A multiplexer is also called as a data selector. So here we are having an input signal and there will be an output signal and there will be an selective signal, selection signals that will be depends upon your number of multiplexes, number of inputs used. Accordingly, we can use the select signals. So in a demultiplexer means one into many. A demultiplexing is a process of taking information from one input and transmitting the same over one of the several output. A demultiplexer is a logic circuit that receives information on a single input and transmits the same information over several output lines. If there are n input signal lines and there are m selected lines, and there will be one output signal line which is equal to 2 power n. So this we can call it an encoder. An encoder is a digital circuit that performs the inverse operation of a decoder, and the opposite of the decoding process is called as the encoding. An encoder is a combination logic circuit that converts an active input signal into a coded signals. It has n inputs and m outputs. So here we are going to see about a binary encoder. That is well known that a binary to an octal decoder, a 3-bit input code, and it activates out of 8 output lines corresponding to that code. So we are having an input as D0 to D7 and an output as Y2, Y1 and Y0. So if you select the D0, then you can get your output as that is D0 0 means 0 0 0. And if you are selecting a D1, if you are giving an input as D1, that is D1 as high, remaining all other inputs are low. So your output will be equal to accordingly the 1, that is an binary output of your 1 is 0 0 1. So same that if you are selecting an input as D2 2, then we can get your output as 0 1 0. Then D3, so it is a 0 1 1 4 1 0 0 5 1 0 1 6 1 1 0 7 1 1 1. So next we can see about a decoder. A decoder is similar to a demultiplexer but without any data input. It is a most digital systems requires a decoding of data. Decoding is necessary in applications such as a data demultiplexing, digital display, digital to analog converters and memory addressing. Each output line will be activated for only one of the possible combination of inputs. A decoder is a number of output is greater than the number of inputs. So here we can see about 3 to 8 decoder. A 3 to 8 decoder has 3 inputs A, B, C and 8 outputs D0 to D7. Based on the 3 input, one of the 8 output is selected. So you are having an input as A, B, C. Accordingly the output will be, so if it is 0 0 0, then D0 will be selected. If it is 0 0 1, your D1 will be selected. 0 1 0, you can select D2 and 0 1 1 3, 1 0 0 D4, 1 0 1 D5, 1 1 0 D6, 1 1 1 D7. It is the opposite to that of your encoder. Next we can see about flip-flops. The simplest kind of a sequential circuit is a memory cells that has only 2 states. It is called as a flip-flops. It is used to store 1 bit of information with a 0 or 1. A flip-flop is also known as bistable, multivibrator, latch or toggle. So there are types of flip-flops. The flip-flops are different types of depending upon the input and the clock pulses cause transitions between 2 states. There are 4 types of flip-flops: SR flip-flops, D flip-flops, JK flip-flops and T flip-flops. The SR flip-flops is nothing but a set reset. D flip-flops, it's called as a delay or data flip-flops. JK. Then T flip-flop, it is called as the toggle flip-flops. So here we can see about your SR flip-flops, that is set or resets. This is a logic symbol for your SR flip-flops, that you are having in two inputs SR and you are having an output as Q and Q dash, or we can say that is Q bar. That is a Q and Q bar. That is, it is a complementary of your output Q. So we are having, when one more signal is there, it is called as the clock signals. It will toggle your flip-flops. So here is this logical circuit of your SR flip-flops and your truth table. Here SR are the two inputs and you are having an QT plus 1, that we can call it as a future next state. That is, Q is called as a present state and QT plus 1 is called as the next state. If you are having a 0 0, your next state will be equal to a present state, that is, there will be no change in your output. If you are having an 0 1 as your input, you are having an output as 0, that we can call it as a, if that is, here we have selected your reset as a high, so that the result is your 0, that is, it will be reset or it will be clear. Then if you are selecting and giving an input as 1 0, you can get your output as your 1, that is, we are selecting an S input as high, so it will be equal to set. And if you are having an input as a combination